Okay, I'm going to work today. No, wait a minute. Going to work today, that's not the same thing as doing work in science. Work is, I guess you could say that work is energy being used. That's a definition that I just made up. You'll see work listed like this. Work equals force times distance. That's also true. Work is measured, matter of fact, in the unit of energy. It's measured in joules. So the easiest problem you're going to see with work is something like this. You've got a force of 10 newtons and it moves something a distance of 2 meters. Newtons times meters gives you Newton meters. Nobody wants to say that, so we named it after the famous dead guy, James Prescott Joule, and there you go. If a force of 10 newtons moves something 2 meters, then it did 20 joules worth of work. Pretty straightforward, pretty simple. What if you lift an object upward? Well, if you apply your force upward, then you're working against gravity. So you can just use F equals ma, or force equals mass times gravity. And that can go in place of the F. So force equals ma, or mg in this case, times the distance. So mass times gravity times distance. Well, what's that? That's actually the same thing as the potential energy equation. Potential energy is just mass times gravity times height, right? Instead of d, it's an h. So it makes sense that they are both measured in joules because they're the same thing. Now, I just want to, before I go, this is going to be a really short video, but before I go, I'm going to draw this. Let's say you've got a floor, and there's a box sitting on the floor, and somebody's going to push the box across the floor, and they're going to move it a certain number of meters, I don't know, 5 meters or something. And let's say there's a wall here, and let's say that this floor is frictionless. Frictionless means that there's no resistance. So if this person somehow pushes this box, it's just going to slide. And if they apply a force of, I don't know, 100 newtons or whatever, you might be tempted to just say, oh, well, then the work is the force times the distance. That's not the case in this problem. Why? Because since there's no friction, no work was done. Basically, work is a difference in energy. And so how much energy does the box have here versus when the box is over to here, let's say? It's no different. There was no heat dissipated by the friction or anything. So that's kind of a tricky question. Or how about this one? Let's say this is a wall, and let's say this person right here is going to push on the wall, and they're going to apply a force on the wall of 800 newtons. And the wall moves a distance of 0 meters. Is any work done? Well, the answer is no. Why? Because the distance is 0. So if the distance is 0 and you put in a 0 right here, then you get 0. But you might think, well, wait a second. If I push on the wall, you know, my muscles get sore, I get all tired, my feet hurt, my legs hurt. I must have done work. Well, that's true, but the work that you did was not on the wall. The work that you did was on your own muscles and bones and tissues. So anyway, that's just a quick 4-minute video on work.